understand the concept of confidence limit and confidence intervals, and explain the testing of hypothesis. Going to our session, let's recollect information about the types of data and how to summarize those data. Continuous and discrete. This continuous can be interval and ratio, and discrete data it can be integer or categorical. Categorical again it can be ordinal, nominal, or binary.
Subhash.
So how to summarize those data? The continuous and integer data most of the time, it's not always, most of the time it follows the normal distribution of the curve. So it is which does not follow the normal distribution curve or summarized as median. Example, the VAS score, GCS score, most of the scores does not follow the normal distribution, so it is summarized as median. Whereas the categorical data are summarized as frequency, proportion, percentage. The special category data, that is a binary, is example is yes or no, present or absent. The ordinal data example mild, moderate, severe. Nominal data example is just like religion, gender. The other categorical data is categorical over period or summarized as incident data. Example, vomiting over every hour, death out of cancer every year. So whatever the data we measure from our study, can it be same as the true value? It may be or it may not be. If it is not, then it can be closer to the true value, or if it is not, it is far away from the true value. How do we find out? For that, we need to know standard error. What is standard error? It is a statistical term that measures the sample distribution, that measures the accuracy with which the sample distribution represents the population by using standard deviation. So, standard error is equal to standard deviation divided by the square root of n. Here n is the sample size. So the standard deviation is always divided by some numerical value. So the standard error will always be smaller than the standard deviation. So for an example, if you take a 200 student of 10 standard student, and their average weight is 47.5 population. So we take a small sample. Here we take a average weight is coming to be minus 50. For example, if the standard deviation for them is 7, and the standard error of sample mean is equal to 7 divided by square root of 25. So we get a standard error is 1.4. So as we say, the standard error is the standard deviation divided by square root of n. If we increase the sample size to 36, the standard, we decrease the sample to 16, the standard error will increase to 1.75. Now we got the standard error. Now can we say our measured value is same as true value? No. For that we need to know confidence limit and confidence interval. What is confidence limit? Confidence limit, it represents the frequency or proportion of confidence interval that contain the true value. Say for example 95% confidence limit, it means that confidence interval has a true value with 95% certainty. That is the 95 out of 100 times that interval has a true value. So from the study, if we apply 2 standard deviation to the mean plus or minus 2 standard deviation. The standard deviation was 7. So the range is coming to be 36 to 64. When we apply 2 standard error to the mean, the standard error was 1.4. So the range is coming to be 47.2. What does this signify? When mean plus or minus 2 standard deviation, it signifies the distribution of data. That is, for 1 standard deviation, 68% of the data will distribute around the mean. When we apply 2 standard deviation, it means 95% of the data will distribute around the true mean. Whereas if we apply 3 standard deviation, the 99% of the data will be distributed around the true mean. Whereas on the other side, the range is 47.2 to 52.8. That means for the 95% confidence limit, that is a 95% confidence interval, the range is 47.2 to 52.8. It has 95% we can say that true value lies within this range. So we have done only one single study. Say what, if we repeat the study for 100 times with different 25 sets of people. So we will get 100 different of means. Like we got a mean of 50, so like that we will get 100 different means. So most of the mean may fall closer to the true mean and few may fall away from the true mean. So it follows the normal bell curve. The curve will be like this. So if we plot those 100 means, these are the different 100 means. We got it from the 100 different study. So if we plot those 100 means against the true mean, so we will have a chart like this. So you derive the standard deviation for each mean and standard error for each mean and apply the two standard error. Since we are having 95% confidence limit, you apply the two standard error plus or minus, that is on both sides of the each mean. Then we get a chart like this. So which means it says 95 times it intersects the true value. Only 5 times it may not include the true value. That 5% error is acceptable. So 95 times we can sure that our value is including the true value. So without repeating our study for 100 times, and also we don't know what is the true mean, from single study we can say that when using 95% confidence limit, we can say that true value lies within this confidence interval with 95% certainty. When we apply 2.68 standard error to the mean, so in that case we can say that with 99% confidence limit, we can say that true value lies within this confidence limit with 99% certainty. So we have finished the standard error and the confidence interval. So how to test the hypothesis? So hypothesis testing. So there are 4 steps. First, you state the hypothesis. What hypothesis? Null hypothesis and alternate hypothesis. Then set the criteria for decision. Then compute the test statistics and make a decision finally. So we have done a test for one single group. What if we do for 2 groups? Say example, 10 standard from one section and 10 standard from the another section. We take a sample size of 25 from each group, and the mean is 50 for the first group and 56 for the second group, and the standard deviation is 7 for the first group and 7.5 for the second group. Here the difference is 6. So again the same logic. Whether the 6 is same as the true value or it is lower or higher than the true value. How do you calculate? Here comes the concept of null hypothesis and alternate hypothesis. Null hypothesis states that mean of the first group and mean of the second group are always equal. So there is no difference. Difference will be 0. If at all we get a difference, that difference has occurred only by chance. So both groups are from the same population. Whereas alternate hypothesis states that mean 1 is and mean 2 are not equal. There will be difference. The difference is real. That does not occur by chance. So both groups are really from a different population. Then set the criteria for decision. What criteria we have to set here is, so when we do a research study, it's not that always we get 100% correct data, right? So there are some chances to be incorrect also. So we have to keep in mind about the 2 types of errors while doing a research. So one is the alpha error, that is also called as type 1 error, and another is beta error, also called as type 2 error. So both, it is not possible to completely eliminate or minimize both the error simultaneously. So hence in practice we keep alpha error as a fixed one. So alpha error here it is 1 minus confidence level. So confidence level, it can be 90% or 95% or 99%. So most of the study we use the confidence level as a 95%. So alpha is equal to 1 minus 0.95. Here we get a alpha error is 5%. So from the above study, from the above 2 group study, which hypothesis to favor and which one to reject? So we got a difference between the 2 group. 56 minus 50, we got a difference of minus 6. So now calculate the standard error and apply the 95% confidence limits. 95% confidence limit, it means mean plus or minus 2 standard error. So example, we take a standard error is 3.2. So apply those 3.2 in this formula. So 6 plus or minus 2 into 3.2. So we get a range of 95% confidence interval is minus 0.4 to plus 12.4. So where the 0 is included. So when the 95% confidence interval includes a 0, which means null hypothesis accepted, the both group are from the same population. There is no difference between two groups. So if we repeat the same study for the both the groups for 100 times, we get the 100 different difference of means. So you calculate the standard error and apply two standard error on both sides. We get a chart like this. So 95 out of 100 times it will intersect the 0. So which means null hypothesis is accepted. Only 5 times it may not include 0. The 5 times error is accepted. So without repeating the study for 100 times, or we don't know what is the true difference of means from the two groups, so we can extrapolate from one single study. If 0 is included, 0 will be included in at least 95%. So probability of the difference to occur by chance is more than 5%. So we cannot reject null hypothesis. So difference has occurred only by chance. So we got a difference, right? 56 minus 50 is 6. That difference has occurred only by chance. So both groups are from the same population. Say example, the standard error we kept it as 3.2, right? So if we get a standard error of 1, then apply this 1 to the formula mean plus or minus 2 standard deviation, here 6 plus or minus 2. So we get a range of 4 to 8. Here the 95%, here 0 is not included. So 0 is not included. So we can say this 0 will not be included in at least 95% study. So probability of this difference to occur by chance is less than 5%. So reject null hypothesis and favor the alternate hypothesis. Both group are from the different population. So in simple, in the 95% confidence interval, if 0 is included, null hypothesis accepted. If it is not included, favoring alternate hypothesis. So we know that if 0 is not included, there is a difference between two groups. So, but can we say that how much significant the difference is? So for that, since it is a continuous data with two different groups, so it is a unpaired t-test is used. So calculated t-value is equal to difference of mean divided by standard error. So the calculated t-value, if it is more than 2, we can say that the difference between the two groups is significant with 95% certainty. If the calculated t-value is more than 2.66, we can say the difference is very significant with 99% certainty. If the value is more than 3.23, we can say the difference is very highly significant with 99.9%. And also the value is, if it is less than 2, null, here the null hypothesis is accepted, so that there is no significant difference between the two groups. Here are the example. I took it from one study. Here the study is nothing usage of using dexmedetomidine infusion versus the normal saline infusion to attenuate the emergency situation in ENT surgeries. So the group C is the control group and group D is the dexmedetomidine group, the drug group. Here the age was compared. Comparison of mean age between study groups. The age was compared. The mean difference is 0.24. We don't know whether this 0.24 the difference is really true, real difference or occurred by chance. So we apply the 95% confidence interval. We got a range -4 to +5. So here the 0 is included. So that the difference is there is no significant difference. So both the group has a in terms of age there is no difference in terms of age. Also the p value is 0.9. which is the probability of the difference to occur by chance. P value is nothing but probability of the difference to occur by chance is 0.9, which is far higher than our desired value, that is P value is 0.05. So from the same study, they were comparing age here. They were comparing the time period between T0 to T extubation. Here T0 is stoppage of the infusion, from stopping the normal saline and dexmedetomidine till the time of extubation. The time period was compared. The mean difference was 2.24. We don't know again whether it is a real difference or not. So apply 95% confidence interval. We got a value from 1 to 2. There is 0 is not included. Also the p value is less than 0.001. The significance is the differences which has occurred is by chance is 1 in 1000. So there is a significant difference between the two groups in terms of time. So how to choose a statistical test? So in the previous lecture, sir and ma'am was talking about the chi-square test, man-whitney test. Okay. So how to choose a test for which hypothesis or for which data? So for that we need to know 5 subheadings. First is type of variables. What type of variables we are going to get, and what kind of distribution it's going to have. Continuous and integer, mostly as I said, it follows the normal distribution, so it is summarized as mean. Whereas the data which does not follow the normal distribution will be summarized as median. The categorical data, mostly the binary data will follow the binomial distribution and summarized as proportion. Type of analysis, whether you are comparing between two groups like lignocaine versus bupivacaine or dexmedetomidine versus clonidine. So comparing one group with another group. Then the second is correlation. Correlation between two variables. Like I am checking a body weight and blood pressure from the same individual and finding out the relationship between body weight and blood pressure. So finding out relationship between two variables. And regression. Regression means predicting one variable from the other. I am predicting, example is predicting gestational age from by using a placental thickness. The third point is number of groups and data sets. Whether one group with 2 data sets or more than 2 data sets. Example, one group 2 data sets means for one group of people I am giving ketamine injection and I am measuring data sets. For example, I am giving spinal anesthesia and I am measuring the blood pressure following spinal anesthesia at 0 minutes, 10 minutes, 20 minutes like that. So multiple data sets. So 2 group 2 data sets as I gave earlier, like clonidine versus dexmedetomidine, more than 2 groups and more than 2 data sets. Study design, as already sir was discussed, it is a so distribution of data, whether it is following normal curve or non-normal curve or binomial distribution. So applying those 5 steps to this table column. Here the only comparison I have given, the association and regression, which is in the coming slide. So the first point was type of variables. That is whether the data follows the mean, normal curve or non-normal curve or binomial. So the data which is following the normal summarized as mean and the median and proportion. The second point was type of analysis, whether you are comparing or finding out correlation or predicting another variable, that is regression. Here the comparison given, the regression and analysis in the subsequent slide. The third point was number of groups and data sets. If it is 2 group and 2 data sets or more than 2 data sets. 2 data sets and more than 2 data sets. And the fourth one was paired or unpaired. Here the paired or unpaired. So fifth one was again the distribution here. So by applying all these things in this table column, we can derive which test has to be used. Say for example, here the A is, and for the second group, the second table, here there was a comparison of Richmond agitation sedation scale. This is again a scale, -4 to +5. The range is -4 to +5. So scale, as I told, it does not follow the normal distribution curve, so it is summarized as median. So that is even the statistician mentioned here, the median of Richmond agitation scale. So the data is median and there are 2 groups which are unpaired. So go back to the previous slide. So apply this median, 2 data sets and unpaired. So man-whitney test. So this is chi-square test and this is man-whitney test. Then next, association and regression. So here the outcome variable is very much important. If it is the outcome variable is continuous, we go for Pearson correlation coefficient test to finding out correlation. For predicting one variable, we go for linear regression test. If the outcome is binary, we go for Spearman rank test and we go for linear logistic regression test. Say for an example here, smoking and cancer. Smoking can be plus or yes or no, and cancer can be present or absent. So this is the binary data. Both are binary data. Outcome is binary, so we choose Spearman rank Spearman rank correlation and logistic regression. In the second example, we use the serum bilirubin level, which is a continuous data, whereas the outcome is neonatal death, that is the binary data. Since the outcome is binary, we go for Spearman rank correlation and logistic regression. If you want to find out association, then Spearman rank correlation. If you want to predict one variable from other, then we go for logistic regression. This is again an example for the linear regression. I got it from one study. So here they have compared, they are predicting gestational age. This is the gestational age from the placental thickness. So by using the linear regression, they derived this equation. Y is the gestational age, that is the dependent variable, whereas X is the independent variable. So they derived the value 0.3747 into placental thickness plus 5.5. This is they derived from the test. This is for the first trimester and this is for the second trimester. For the equation they derived. On conclusion to this study, on conclusion of this session, just 4 points you have to remember. What is standard error? So we need a standard error to find out the confidence limit. So when we have a 95% confidence limit, if it includes 0, then null hypothesis is accepted, and if it does not include 0, null hypothesis is rejected. So how to do hypothesis testing? First you state the hypothesis and set the criteria like alpha error 5% or 10%, whatever the set the criteria. Then you third you choose the test, statistical test. For choosing the statistical test, we have to apply those 5 criteria to the tabular column, then we can choose the test. Then apply your data and get the result. Then once you get the result, then make a conclusion. Yes. Thank you.
Why you told? Then always we want, our idea is ultimately because we want to show that this one is less than 0.05. That is the this. Then he has mentioned less than 0.001, where you have to tell significant, highly significant, very high number. I will appreciate his sincere efforts